Measures of central tendency, variability, and spread summarize a single variable by providing important information about its distribution. Often, more than one variable is collected on each individual. For example, in large health studies of populations, it is common to obtain variables such as age, sex, height, weight, blood pressure, and total cholesterol on each individual. Economic studies may be interested in, among other things, personal income and years of education. In this chapter, we consider bivariate data, which consists of two quantitative variables for each individual. Our first interest is in summarizing such data in a way that is analogous to summarizing data on a single variable. By way of illustration, let's consider something with which we are all familiar: age. It helps to discuss something familiar, since knowing the subject matter goes a long way in making judgments about statistical results. Let's begin by asking if people tend to marry other people of about the same age. Our experience tells us yes, but how good is the correspondence? One way to address the question is to look at pairs of ages for a sample of married couples. This table shows the ages of 10 married couples. Going across the columns, we see that, yes, husbands and wives tend to be of about the same age, with men having a tendency to be slightly older than their wives. This is no big surprise, but at least the data bear out our experiences, which is not always the case. The pairs of ages in the table are from a dataset consisting of 282 pairs of spousal ages, too many to make sense of from a table. What we need is a way to summarize the 282 pairs of ages. We know that each variable can be summarized by a histogram and by a mean and standard deviation. Each distribution is fairly skewed with a long right tail. Although some wives are older than their husbands, this information cannot be determined from the histograms or from the means and standard deviations. Another example of information not available from the separate descriptions of husbands and wives' ages is the mean age of husbands with wives of a certain age. For instance, what is the average age of husbands with 45-year-old wives? Finally, we do not know the relationship between the husband's age and the wife's age. We can learn much more by displaying the bivariate data in a graphical form that maintains the pairing. This figure shows a scatter plot of the paired ages. The x-axis represents the age of the husband, and the y-axis the age of the wife. Each blue dot represents one married couple. The graph shows clearly that there is a strong relationship between the husband's age and the wife's age. The older the husband, the older the wife. When one variable, y, increases with the second variable, x, there is a positive association between x and y. Conversely, when y decreases as x increases, there is a negative association. A second characteristic of these data is that the points cluster along a straight line. When this occurs, the relationship is called a linear relationship. This figure shows a scatter plot of arm strength and grip strength from 149 individuals working in physically demanding jobs, including electricians, construction and maintenance workers, and auto mechanics. Not surprisingly, the stronger someone's grip, the stronger their arm tends to be. There is therefore a positive association between these variables. Although the points cluster along a line, they are not clustered quite as closely as they are for the scatter plot of spousal age. Not all scatter plots show linear relationships. This figure shows the results of an experiment conducted by Galileo on projectile motion. In the experiment, Galileo rolled balls down an incline and measured how far they traveled as a function of the release height. You can see that the points do not fall in a straight line. If you drew a line connecting the lowest point and the highest point, all of the remaining points would be above the line. Scatterplots that show linear relationships between variables can differ in several ways, including the slope of the line about which they cluster, and how tightly the points cluster about the line. A statistical measure of the strength of the relationship between variables that takes both these factors into account is the subject of another section.